Imagine if all the software running our world suddenly ceased to exist. What if I told you that the software running on your phone, the algorithms predicting the weather, and the code embedded in rockets and satellites all trace their roots back to a single profound idea conceived over 2 centuries ago? To truly understand software, we'll need to venture back to 1819, where we find Charles Babbage, a mathematics professor at the University of Cambridge. Babbage was disillusioned with the countless errors in the mathematical tables of his time. He envisioned something radical, a mechanical device that could compute these tables faster, more accurately, and tirelessly. Charles Babbage was a visionary, born at the height of the Industrial Revolution in London, a city transformed by machines and innovation. Surrounded by the hum of progress, Babbage saw the potential for machines to do more than just physical labor. Inspired by the precision of clocks and the power of steam engines, he imagined a new frontier, machines that could think. To avoid errors and excessive repetition, Babbage conceived the difference engine, a machine to perform flawless mathematical calculations on demand. This was not just a clever invention, but a bold challenge to human limitation. Yet his vision faced a harsh reality. The technology of the 19th century was not advanced enough to bring his ideas to life. Precision engineering was rudimentary, and crafting the thousands of parts needed was nearly impossible. The government funding he relied on was cut, leaving the project unfinished. Despite the financial setbacks, Babbage dreamed even bigger. He envisioned a machine that could be programmed, a machine that could process or think independently. This was the analytical engine, the world's first concept of a programmable mechanical computer. It was a vision far beyond his time, misunderstood and underappreciated by his contemporaries. Despite the lack of support and the impossibility of the task, Babbage never scaled back. He saw the future of computing, a future that others could not yet grasp. Introducing Ada Lovelace, a brilliant mind, a visionary, and daughter of famed poet Lord Byron. Raised by her mother to value mathematics and science, Ada's path would cross with Babbage in a fateful meeting that would change the course of computing history. Ada saw something in Babbage's analytical engine that even he hadn't fully grasped. In her seminal notes, written while translating an article about the engine from French to English, Ada foresaw a future where such machines could do much more than just compute numbers. They could weave patterns, compose music, even think in a rudimentary form. In these notes, she outlined what is considered the first algorithm, earning her the title of the world's first computer programmer. Her work wasn't just technical, it was philosophical. Ada questioned how machines and humans could interact in a symbiotic relationship where technology amplified human capability. Her foresight was remarkable. Ada Lovelace envisioned a future where machines could go beyond mere arithmetic operations to handle more complex and more abstract tasks, a vision that aligns closely with modern computing's core concepts. She was far ahead of her time. The seeds planted by Babbage and Lovelace would take decades to grow, but their ideas were never forgotten. In the late 19th century, a series of groundbreaking innovations in electricity, communication, and mechanics would redefine the future of technology. Thomas Edison, working in Menlo Park, invented the electric light bulb in 1879, setting the stage for a world powered by electricity. Meanwhile, Nikola Tesla pushed the boundaries of electrical engineering, developing the ability to transmit and generate alternating current, a technology that would become the backbone of modern electrical grids. Tesla's vision didn't stop there. He also experimented with wireless transmission aiming to transmit energy and information without wires, a precursor to modern wireless communication. The devastation of World War I accelerated many innovations that became crucial to society's progress. Henry Ford's version of the assembly line significantly improved efficiency, enabling the mass production of military vehicles and equipments. This greatly supported the Allied efforts during World War I. The internal combustion engine, the radio, the vacuum tube, the airplane. These technologies laid a foundation for even more astonishing advancements approaching World War II. The Roaring Twenties. It transformed entertainment with the widespread adoption of radio, the evolution of gramophones, and the introduction of sound to cinema. These innovations didn't just change how people enjoyed music and movies, they also laid the groundwork for today's digital media, influencing how we store and share sound and video. The 20s took on rapid growth in mass production and electrical engineering. But we need to jump ahead. One young British mathematician found himself uniquely inspired. Alan Turing. His ideas would forever change the landscape of computing. Inspired by mathematical foundations laid by his predecessors, Turing sought to formalize the concept of computation. In 1936, Alan Turing published a groundbreaking paper introducing the concept of the universal Turing machine. This was a theoretical idea, a machine that could follow instructions to solve any problem. As long as the problem could be broken down into steps, it was a vision of what computers could become. Machines that could be programmed to do anything. But to understand how Turing got here, we need to look at the world he lived in. In the early 20th century, mathematicians like Kurt Gödel were exploring the limits of math itself. Gödel proved that any system of rules, there are things that can't be proven one way or the other. This shook the world of mathematics and deeply influenced Turing.